Next up is Carly Pieters, and she's talking about where to obtain samples of a key unsampled lunar rock type, and of course, Mg-Spinel Anorthosite. Carly, you have 5 minutes.
Okay, the summary of the questions that was asked are listed here on the lead-in slide, so I'm not going to go into any detail. However, I have, in the last few days and hours, readjusted 3 and 4, so I want to change that in the discussion. Next slide, please. What is Mg-Spinel Anorthosite? Well, it's a highland, or essentially a crustal material that has signatures of just Mg-Spinel and plagioclase. Mg-Spinel is a gem-like ruby. It's beautiful and readily detected with remote sensing. On the left here are samples from the moon. The 2 spinels are Earth-based samples, but it shows the signatures in the spectroscopic range that we've been working with. On the right are similar data from M-Cube, which identifies the character of the Mg-Spinel. Throughout this, I'm showing the Mg-Spinel as green, just for clarity. Next slide, please. This shows the distribution of where the detections of this particular rock type is found. Notice they all are occurring in areas of thin crust. The 3 areas I target for potential sample return are actually on basin rims that give us some character of the location of the origin of these particular materials. Next slide. These are the 3 areas, Theophilus Central Peak, an area in Mare Imbrium, and an area on the far side in the crater Thomson. My favorite is actually the Theophilus Central Peaks, and I think if I had all my preferences aligned, I would go to the Central Peaks of Theophilus. The second area is on the far side in South Pole Aiken. Next slide, please. Shown here is what the sequence of stratigraphy is included in each of these sites. They each start with a basin impact and then subsequent activities that allow us access to the sampled sites. The third area is in the middle of Imbrium, which has had the Imbrium basin formed, and then Mare basalts filling the basin, giving us access to that particular site. So the third site may be the easiest to access, whereas my preference is Theophilus Crater Central Peaks. Next slide, please. This is where the Imbrium site is. It's in an area that has been identified as a likely inner ring of Imbrium, which allows deep-seated material to be exposed. Next slide. Oh, that's going backwards. Next slide. Next. Okay, we've measured it 3 times with M-Cube, and we see the same thing each time. Shown there in those little green strips is where the Mg-Spinel Anorthosite is exposed. So we're quite confident with them. I'm going to show you using a NAC image in the, don't go there yet, in the next slide, of what the site looks like close up. Next slide. Okay, here we have the NAC image. I realize you probably can't see the scale, which is 500 meters, but those 2 craters in the lower part of the image are approximately half a kilometer apart.
1 minute, Carly, 1 minute.
Okay, I'm almost done. The massifs there are what contains these 2 areas of Mg-Spinel that has been beautifully exposed. So what I would propose is that we land in the debris downslope of those massifs, so you have to have pinpoint landing, and I recommend, as I know Clive has recommended, 2 kilograms of bulk sample, and I think we've got it. Next slide. if we want to be more ambitious, we can put a mobile in there and go up the slopes and go to them and catch a sample right on the ridge. That might be further in the future. Thank you. Oh, this is Magnesium Spinel, Team Spinel.
Thank you very much, Carly. And on time. Brilliant.